Hi everyone, I'm back again. I'm here to do LeetCode problem number 121, best time to buy and sell stock. You're given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return zero. Okay, so these are the days, right? I think it's day 1, 2, 3, 4, 5, 6, and so it tells you that the answer is 5 because you should buy the stock on day 2 and then sell it on day 5. 6 minus 1 is 5, right? That is the answer and that is the you buy on day 2, sell on day 1, 2, 3, 4, 5 at a price of 6, and so you made a profit of $5. It says note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell, right? So you can't buy on day 2 and sell on day 1. That makes perfect sense. And then this one is the answer is 0. The stocks are all decreasing in value, so you don't make any profit. Okay. In this problem, it's not hard. This is this you can solve in a myriad of ways, but I'm gonna demonstrate the 2-pointer approach. You have the right pointer that keeps just it's actually the tortoise and the hare approach. You have a right pointer that just keeps trudging along, and you have a left pointer that is always pointing to the minimum, the minimum of the stocks. And every time you encounter an increase, right? You have one day, and then a day that follows that one day, if there's an increase in price in the stocks, you calculate the maximum price and see if it's bigger than the previous maximum. If so, then you update the max until in the end you return the max. So give me 1 second. My computer needs to charge. Okay, I'm back again. Let's get started doing the problem. Constraints. One is less than or equal to the prices dot length, which is less than or equal to 10 to the 5. So the length of the array that you're given can get pretty big and unwieldy. And 0 is less than or equal to the prices of I, which is less than or equal to 10 to the 4th, which means that the values themselves can be as low as 0 and as high as 10 to the 4th. This, I think, this is a 2-pointer problem. But this can also be solved in a myriad of different ways. Array and dynamic programming. So this is also an array or dynamic programming problem. So let's take a look at the approach. Define a variable that will serve as the max profit variable. Then what you're going to do is return this variable, right? Return this variable at the end. Then what we're going to do is define left and right pointers that are 0 and 1, loop through the prices list while right is less than or equal to less than length of the prices. If we found that the next day's price is if we found that the next day's price is greater wait, this is not wrong. If we found that yesterday's price is less than today's price, see if we update the max, let me just call this max, update the max profit, else set left equal to right, because if we found that yesterday's price is less than today's price, then we update the max profit. But if yesterday's price is if we find that yesterday's price is less than yesterday's price is greater than today's price, then you set L equal to right, such and maintain that this is the new minimum price. Return the answer. Yeah, I think that's it. Let's try it. Let me just make sure one thing. There's also the fact that the prices.length is could be equal to 1. So if it's equal to 1, then you can't return anything. So let me try doing max profit equals 0. Then you have LR equals 0, 1, if, and then I'm going to do N equals len prices. If N is less than or equal to 1, return 0. While R is less than N, if prices L less than prices R, right? If prices, then you update the max profit. Max profit equals max profit, not equals max profit, comma max profit, comma, how about this, prices R minus prices L, right? So that's what it is. And then else, this is what we're talking about. The left pointer will always point at the lowest price, but if the right pointer points at a price that's even lower than the left, then you have to do L equals R, and then you do the right pointer is always going to increase, and then you return the answer. Okay, very good. So this is the solution, and its TC is O of n, and the SC is O of 1. Time complexity, you're looping through all the values within prices. space complexity of 1, no new data structures are being developed. Okay, this is not a tough problem, but it is very tricky. I do want to check one thing. If I just remove this, will this still submit? Will the algorithm still work? I'm just curious. Okay, it does. So you actually don't even need like the if statement. Yeah, so right, you don't need the if statement, and you can't always rely on the LeetCode interface, right? Sometimes the runtime and the memory, they'll just do their things and not always give you accurate readings. So I guess you don't need that check is because when you have right is less than or equal to n, that is by default the check. If n is 1 and r is 1, then this is just not gonna run. So this is actually genius right here. It saved you some work. Okay, so thank you very much, everyone, and I'll see you at the next one.